We're looking at a starting system diagram here. I want to point out a couple of the parts and the connections that are made so we can understand what these meters should read in a working circuit. Over here we have the starter motor. My rule of thumb when I look at wiring diagrams is always find the load that you're diagnosing. In this case, here's the starter motor. Okay? Here we have the starter relay. Before the starter relay, on the battery positive side, we have an ignition switch. Up here, we have a park neutral safety switch to prevent us from starting the car and any gear except park or neutral. Down here we have an anti-theft module, okay, that is going to prevent us from starting the car if any anti-theft conditions aren't met. On the starter, we have a starter solenoid, and we also have a battery here. First question is, what should voltmeter number 1 read? Okay, if we look at voltmeter number 1, the positive lead is connected to the positive side of the battery. The negative lead is connected to the negative side of the battery. This is always a great place to start any electrical diagnosis. Voltmeter number 1 should read 12 volts. Okay. Question number 2. What should voltmeter number 2 read with the ignition switch open? And what should voltmeter number 2 read with the ignition switch closed? Okay. So let's take a look at voltmeter number 2 over here. Okay. Voltmeter 2 is connected to ground, okay, at the starter motor. So this would look like the engine block. It's connected to the battery positive lead on the solenoid, okay. The battery positive lead to the solenoid is coming from the high current side of the relay, okay. So with the ignition switch open, the relay will be open. The meter should read 0 volts. With the ignition switch closed, the relay should be closed with a battery positive connection to the solenoid. The meter should read 12 volts with the ignition switch closed. All right. Number 3. What should voltmeter number 3 read with the ignition switch open? And what should voltmeter number 3 read with the ignition switch closed? Take a look at voltmeter number 3. The negative lead is connected to battery negative or ground. Okay. I like to assume that the negative lead on the battery is always a known good ground. The positive lead is connected to the low current side of the relay coming from the ignition switch. So with the ignition switch open, voltmeter number 3 will read 0 volts. With the ignition switch closed, voltmeter number 3 should read 12 volts for battery voltage. Okay. Question number 4. What does voltmeter number 3 test? And we're looking for what connections and components does voltmeter number 3 test? Well, let's look where volt number 3 is connected. Okay. To ground and between the battery and the ignition switch. So, with the switch open, the meter should read 0 volts. With the switch closed, it should read 12 volts. Voltmeter number 3 is checking the function of the ignition switch and all the connections between battery positive and the relay. So by connecting our meter here, we've tested the switch, the lead between the switch and the relay, and the lead between the battery and the switch. Question number 5. What does voltmeter number 2 test? Okay. Let's take a look at voltmeter number 2 over here. Voltmeter number 2 is connected to the battery positive lead going to the solenoid, okay, coming from the relay. So, if voltmeter number 2 reads 0 volts with the ignition switch open, and it reads 12 volts with the ignition switch closed, it's testing the switch, the function of the relay, okay, high and low current. It's checking the park neutral safety switch, it's checking the anti-theft module, and it's checking the ground. It's checking the entire control side of the starting circuit. This test does not allow us to pinpoint any one of these, okay? If it reads 12 volts when the switch is closed, you can say all that is good. It also says the opposite. If it does not read 12 volts with the switch closed, you can say any one of those components or connections could be bad. All right. Number 6. Excuse me. What should voltmeter number 4 read with the ignition switch closed? This one's a little bit different than the last test we did. Voltmeter number 4 is connected to the battery positive lead on the solenoid, on the ground side. On the ground side of our meter. It's still a battery positive side of our circuit. The battery positive connection on the meter is connected to the battery positive. So we're testing on one end of the orange wire and the other over here. These are both B+ sides, okay? So, with the ignition switch closed, the relay closes, the solenoid closes, it makes a connection across the solenoid and runs the starter motor, okay? Voltmeter number 4 should read 0 volts, okay? Less than 1 volt. Because we're connected on 2 battery positive connections right here. If we see voltage during this test, this is considered a voltage drop test, okay? If there is a voltage drop, that's an indication that there is resistance. There should not be resistance on this wire, okay? If there is resistance, your starter motor is going to turn slow. It may not turn at all, okay? If there's resistance, it's going to build heat up in the conductor. So a way to test the battery positive connection from the battery is to do a voltage drop test this way. This is preferred over a continuity test. We're using our voltmeter as an ohm meter because if we measure resistance of this wire, the ohm meter only measures resistance of the best strand of wire. So if we looked at this wire and we cut it open and it had 40 or 50 strands of wire, okay? And 49 out of those 50 strands of wire were corroded or cracked, but there was one good strand. Using an ohm meter to do a continuity test would only test the one good strand, okay? One strand is not going to be enough to power the starter motor with the 100 to 200 amps it needs to turn over, okay? When you flow that high current through the wire, because there's only one strand, there's going to be a resistance. It will show up as a voltage drop. That resistance is a load in the circuit, and it's a load that you don't want to have. So we looked at measuring voltage on the control side of the current, or the control side of the circuit, and we looked at measuring voltage drop on the high current side of the circuit. There's another connection, another high current connection from the starter. This is our high current battery positive connection. There's a high current ground connection through the engine block back to the battery. So this is a cable going to the engine block, and we could do the same voltage drop test from this point to this point.